What are the advantages and disadvantages of each of these three AFM imaging modes, and how can this information help researchers choose the best imaging mode for specific experiments? How do the results from AFM testing, specifically in relation to the elastic modulus, contribute to the understanding of the components and stability of the SEI solid electrolyte interface film? In what way can AFM be used to analyze the SEI film's properties, and how does this process aid in the investigation of its structure and behavior? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the development of in situ SEM scanning electron microscopy and AFM techniques benefit the study of electrochemical reactions, particularly when it comes to avoiding the oxidation and stripping of the SEI film during testing? What specific advantages do in situ SEM and AFM techniques offer for observing the SEI film in real time, and how do these methods provide more accurate and reliable data compared to traditional techniques? What role do in situ testing methods play in ensuring the integrity of the SEI film during electrochemical testing, and how do they help preserve the film's natural state for more precise measurements? What specific details regarding in situ testing will be covered in the in situ testing section, and how do these techniques complement the analysis of the SEI film in the context of electrochemical reactions? What are the main advantages of the contact mode in AFM, and how does it enable the acquisition of high-resolution images by directly contacting the sample surface with the tip? What potential drawbacks does the contact mode have, particularly in relation to the possible damage it can cause to both the sample surface and the AFM tip, and how does this affect the overall quality and reliability of the imaging? How does the non-contact mode in AFM work, and what benefits does it offer, such as preventing any contact between the tip and the sample surface, thereby reducing potential damage to the sample? What challenges are associated with the non-contact mode, such as its lower resolution, slower scanning rate, and its specific suitability for only hydrophobic surfaces? How does the tap mode in AFM operate, and how does it balance the benefits of both contact and non-contact modes by making intermittent contact with the sample surface? In what ways does the tap mode offer resolution that is comparable to contact mode, but with less potential for damage to the sample surface, and how does it allow for scanning in liquids? What are the limitations of the tap mode, such as potentially slower scanning speeds compared to the contact mode, and how might this impact its use in certain research settings or experiments? How do the advantages and disadvantages of these three AFM imaging modes, contact mode, non-contact mode, and tap mode, influence their selection for specific research applications?